All right, we can start wherever you want to start. We can do as many. We can do the same type of problem 3 times in a row. We could do different problems, but I'm happy to work any and all types of problems. But I'm not just going to start at number 1, so I'll let y'all figure out what are the hardest. If you want to go and grab it on your phone so you can scroll through and look for which types of problems seem like they'll be the most trouble, we'll just spend 2 literal whole days reviewing for the final. And if you want to stay through 8 o'clock for the second class, you're welcome to stay through 8 o'clock and just study for the final for 4 hours. If that's what you want to do, that's what we'll be doing. 12C, love it. Let's get started. 12. C. Oh, man. These are good problems. But yes, this will be there. If it's showing up here, it might show up on the final. It is fair game. That doesn't make it fun. But it does seem that they will give you the formula so you don't have to memorize that formula for the difference quotient, as they call it. Okay? So. Sorry. 12C. Here we go. I'll post these notes online, and I will also post this video online. So you can go back and watch it a million times if you want to. If we're doing C, yes. No, absolutely not. That sounds like so much work. You just scroll through and see, and when you see, what? That's so much work. Maybe over the winter break I'll add them for the next class, but no way. No. Like add timestamps and put problem number 12 on the review, problem number 13. Interesting. I don't even know how to do that. Can't be too hard. I'll try. I will try to add timestamps. I have a lot to do. I gotta busy. Like as soon as I get out of here, it's gonna be busy. All right. So here's what I think is the best thing to do for this type of problem. Which I know when you're taking the final, you might not have a colors in your pencil, but to look at this as technically 3 different problems. This is technically the red problem minus the blue problem divided by the green problem, right? Yeah. That's how I look at it because it's like I don't want to look at the whole thing as one long problem. I want to look at it as 4 different problems. So let's just solve the red problem and not even worry about the rest of it right now. Let us just solve the red problem. F of x plus h. So we're going to see. So what is f of x plus h equal? Anybody have any inclinations off the bat? For every x, you plug in x plus h. Just like if it said f of 1, everybody would have known what to do there, right? You literally would have just got 1 minus 4 plus 3, right? You would have been like, 1 squared minus 4 times 1. Like, if we would have given you a number, it would have been easy. The only hiccup here is that they don't give you a number. They give you x plus h. So let's plug it in and see. So we get x plus h squared minus 4 times x plus h plus 3. And before we move on to the blue problem, let's solve it out. This is also known as x squared. Yeah, you're right, FOIL. No, FOIL is good. Plus 2xh plus h squared. So this one was I'll do it in pink. FOIL. This one was a distribute, right? Minus 4x minus 4h plus 3. Anything combined, cancel, or go away? No. Interesting. Sometimes it does. Didn't at that time. That's okay. All right, let's move on to the blue problem. What is f of x? Just the normal thing. And the green problem, what is h? Not a trick question, what's h? Indeed. So now let's put all of those together. Let's go. Red problem in big old parentheses minus blue problem in big old parentheses divided by? Excuse me. Mm-hmm. But before we do that, we need to distribute this negative sign to all three terms. So we should get x squared plus 2xh plus h squared minus 4x minus 4h plus 3 minus x squared plus 4x minus 3. All over h. Do it in pink this time. Anything cancel. Oh, shoot. Good call. Boom, boom. Boom, boom. Boom, boom. And now we're left with 2xh plus h squared minus 4h all over h. Look at that. You know what else happens? Boom, boom, boom. Not the whole thing, just one of them, right? It reduces by 1 because we only had one h to cancel. So you should be left with 2x minus 4. I'll zoom out. Love it. It's not super difficult. It is super long. It's a long problem.
You know what's easily forgotten though? It's the same concept of plugging in the number where we see x plus h.
Yes. I do think this is the thing that is the thing to remember. That when you see x plus h, you plug it in just like you would a number. You don't plug in h. You don't just plug in h like you would a number. You plug in x plus h, right? That would be the tricky thing that I've seen some people do is they just plug h in because like, oh, the x was already there. We just switch x for h. That would be if you saw the literal thing f of h. Then you would plug it in, right? But I have seen some people say, oh, because there was already an x, we're just going to put the h in. No, that would not be good. Good question, though, because that is an important one to practice. I would super suggest you practice the other ones because it's awesome.
Can we do one with the how to determine whether a polynomial has axes of symmetry?
Axes of symmetry? Yes, we can. Because that's like from obscure time, long time ago, once ever, right?
That's 27.
Thank you for that. Determine whether it has an axis of symmetry. Okay, so there were really there were 3. I was going to say there were only 2 types of axis of symmetry, but there were 3 types. Does this ask you for a specific type or? Oh, it doesn't. It just asks you for axis. Okay, so there's 3 different types. And even if you don't know how to find them, you could definitely figure out like what those 3 types of symmetry are. Like without knowing this is not pretty. Without knowing anything about the polynomials themselves, I could tell you what this function has as an axis of symmetry right here. Is that little parabola symmetric at all? Looks like that, right? Okay. That's just an interesting thought. Okay. Symmetry is a thing that exists for some things and not other things. Is this one symmetric? Just this line? Not really. It doesn't like flip, right? So there's 3 different types of symmetry. And the test is actually much easier than it sounds like it should be. The test for symmetry is just plugging in negatives. And you just got to decide where you're plugging negatives into. So watch this. Yeah, you're just plugging in negatives for your x. So watch this. If f of negative x equals f of x. Okay? So it's kind of weird to think about. But if on the left side of the equation, because that's negative x, right? It's the exact same as the right side. So if f of negative x is the exact same as f of x, What type of symmetry does that graph looks like it has? Vertical, which is called, what's that vertical line called? That green line's called. Yeah. It's called y-axis symmetry. Good call. Okay? And I'm just reasoning this out, honestly, for two reasons. One, this is how you can reason it out if you forget, if you don't just memorize it. And two, I forgot, so I'm reasoning it out to see the answer. So, if negative f of x equals f of x. So that's on the outside. Oh, wait. Whoops. That would be silly. That would be not a thing. I meant to say if negative f of x equals f of negative x. Okay? So
Would that be a x-axis thing?
let's find out. So if you plug in a negative x number, like right there, right? And you get some f. If you plug in the positive x number, ooh, what happened? So look, if I plug in the negative x number and I get some f right here, that's a positive. And then I plug in the positive number and I get some number that's a negative, what was that symmetric across? The origin, right? And I lied about 3 types. There's only 2 types. Those are the only 2 types. There's no x-axis symmetry. Why is there no x-axis symmetry?
That wouldn't be
Because it wouldn't be a function. If there was x-axis symmetry, that wouldn't be a function, literally. So those are it. So that was a long way around trying to remember the types of symmetry. Here's the short way of plugging it in and seeing. Pick one. Yeah, don't be confused. We'll pick one and see. Pick one of those guys. Oh, I guess there's neither. We should have said neither. If neither of those happen, it's neither. Let's see. You said B? Here we go. So we're going to plug in negative x and see what happens. Y equals 5 times negative x cubed plus 2 times negative x minus negative x minus 3.
2 times negative x b squared.
Was it supposed to be? Good catch. Okay. Something interesting happens to some of those and not others of those. Right?
So every time we get the equation, we always plug in the negative x?
Pretty much. And then we're just seeing, did it completely flip signs? Did it not change at all? Or is it a completely new random equation? That's kind of what we're asking ourselves. So what happens to, what happens to this red negative sign? It stays negative. We're actually allowed to just write it as negative 5x cubed. What happens to this green one? It literally goes away, right? It's kind of non-existent. It's not, but it didn't change, right? It's not going to change the sign because a negative x squared is just x squared. What happens to this blue set of things? It flipped, it goes away, but it also flipped the sign, right? And then the last thing's the same? Okay. So here's the question is, was it consistent? Is this thing, let's call it, what do you want to call it? Let's call it new thing. Let's call it y2, I guess. I don't know. I don't want to call it y2, actually. I want to call it y star. Y prime is what people do a lot of times. Is this the exact same as the thing above it? No. So what can we say right away? Which two are the exact same? Y-axis would be the exact same. So it is not y, because it's not the exact same. It would have to spit out the literal exact same thing, which means that all of them were even. Right? That would mean all of them are even. So, not y. Now let's see, is it exactly the opposite? Did every single thing flip signs? This one flipped. This one did not flip. Oh, well, crap. So it's not completely flipped either. So it's not origin. So it's neither. Let's check out C, because C, I'm pretty sure, has y-axis symmetry, which we can know. Watch this. Y equals 3x squared plus 4. Check this out. You don't even need to know the rules of symmetry because you know how to graph that thing. What is that thing? Is it happy or sad? Where's the y-intercept? So it's a happy parabola at 4? Does that thing have a line of symmetry somewhere? By golly, it does. It has y-axis symmetry. Now let's check it with our rules. We plug in negative x and you get y equals 3 times negative x squared plus 4. It's the same thing, right? Because negative x squared is just x squared. So this is the same as this. So which means y-axis. None of those examples are origin symmetry. I should have made one up. Every line, pretty much, that passes through the origin. So like, watch it. I'll make an origin symmetry up and then we'll move on. Y equals 4x.
What is our final?
Monday from 5 to 7, I'm guessing. Okay. Monday from 5 to 7. Next Monday. In 6, what? On Monday. In 6 days.
Can I ask something quick?
Yeah.
About that thing where it says negative fx, like you negate the function itself.
Which one are you talking? Oh, you're talking about this thing?
Yeah.
What that thing means is that, you negate the function. So if you were checking it, there, look, we're about to do it. We're about to do this is origin symmetry. Watch this. Watch this. Watch it. I'll show you what I'm talking about. If you plug in 4 times negative x, what do you get?
Negative 4.
Okay, now start over. Start brand new over. If you negate the function, if you just throw a negative sign in front of there, right? What is negative y technically?
Negative 4.
Negative 4x. Is that the same thing as negative 4x?
Yeah.
Yeah, it's like negative 1 times 4x, right? So look at that. Y equals negative y. Origin symmetry. Does that make sense that has origin symmetry? I don't know. Let's see. What is that? That's just a line with a slope of 4 passing through the origin. Does that look like there's a symmetry around the middle? Like every point, if I flip it across the middle, it'll do the same thing? There you go. No matter what you do, every single point on this, if you go to the middle and then go the same distance, it'll be on that line.
Why is it positive 4 on
That's basically y equals x.
the line?
Why is it positive 4? Where is it positive? I just made it up. This is made up. Here, I'll write it. Because none of those examples technically had origin symmetry, and I just wanted to make one up that I knew had it, and that's the easiest type to make up that has origin symmetry. The cubic function also, if you want to go check this at home, the cubic function also has origin symmetry. It looks like that, right? Every line you draw, if you keep going through the origin, falls on the line, no matter where you draw it at, right? No matter, boom. So if you want to check at home, maybe you could go and do a little practice problem and check the cubic function and see if it has origin symmetry.
So just check symmetry, just
Plug in negative x and look for those two cases right there. If it's exactly the same, or if every single term flips sign. Those are the only two things that can happen. Otherwise, it's neither. Cool? Okie dokie. What else we got? Do not be shy. We only have 4 hours left until our final. Together. We only have 6 hours left together all year. Makes me sad. Pull it up on your computer or your phone. Look through it. Absolute value? These are, a lot of these. If you really scroll through it, a lot of these are a long time ago, like test 1 and never again. So it is, tell me the number, please. Thank you.
So the absolute value we get.
Ooh, this is fun. Yeah, I was going to say, this is like a long time ago. It's okay though, because we're not gonna memorize formulas like we did last time. I don't want to memorize formulas. I want to reason through it and think through what it's saying, what it's asking. All right, which one do you want to do? One of the ones that has the extra little tidbit? Yeah, I agree. So let's do this. 5, big ol' absolute value sign, minus 7 equals 38. I think we should get the absolute value by itself. Don't you? Love it. Add 7. 5. Absolute value. Well, I'm bad at math. 42. 45? Thank you. Ooh, look at that. That's nice of them. They did us a nice thing. Divide by 5. Divide by 5. You end up 9 minus 5n. Here's where we have to know anything, or we don't have to know. We can reason through it. If we think back to elementary school, not even to this class, elementary school, what did absolute value mean?
The position between 0 and that number itself, or how much value.
Yeah, like the absolute value of -4 was 4. Like here's just an example in our brains because this is what I would remember. If I were taking a test, I'd think this. I'd be like, well, hang on, I know this, and I know this, right? That's what my brain would do on a test. I would say, that's all I know about absolute value. And then you know what I'd immediately do instead of a 4 and a -4? Not to the problem, just looking at that blue section, my brain needs to do something to make up this rule that I don't know. I know the rule, but I'm saying if you don't know the rule, I'm looking at that, I'm thinking, what's the rule that makes that true?
The rule that says that it's the distance of each number.
No, I don't want words, though. I don't want words. I want the rule without a 4 in there.
Okay.
No 4, though. 4 doesn't help me. What does help me? What's the rule that makes that true? 0? No, I'm just saying, like, how can this help me with the problem we're working on?
There could be negatives and absolute.
There can be negatives inside of that absolute thing?
No, there can't be.
There can't be? Oh!
Wait, hold up. So basically, we cannot get negatives as our answer.
Basically, even if it were going to be negative, it would have to spit out no negative, right? Okay. Okay, now we're getting somewhere. But, so here's the question, though. What was -4 supposed to equal? No, what's negative this? The answer to that is that, right? So what did that absolute value sign do right here? It flipped it, but only if it was negative, right? So the absolute value just flips the sign if it's negative and doesn't flip it if it's positive. Now, how can that help us here?
Basically, that -5 would become +5
If
it was by itself.
Yeah, if it were by itself. Yeah, if it were negative. Watch this. This is what I'm going to do. Arrows. 2 types of problems we just said, right?
Oh, yeah, we get a positive and a negative.
There's 2 types of problems. We just said there's two situations. 2 situations happen. If it's positive, stays the same. If it's negative, it don't. All right? So here we go. Let us get rid of that absolute value sign. I'm going to show you the shortcut if you want to just memorize this. Here's the shortcut. Boop. Done. 9 minus 5n equals what? 9, but also 9 minus 5n equals done. Well, we're not done. Now we have 2 problems to solve. So -5n equals 0. N equals 0. Also, blue side, -5n equals Negative 18. N equals. There's your two answers. Do I trust myself right now? Heck, no. I was going to say no. Heck no, I don't trust myself. Watch this. 5. Big ol' absolute value sign. 9 minus 5 times. Which one are you going to try first, red or blue? Yeah, 0 is actually easier. Good call. Bracket minus 7. 5 times 9 minus 7. What's the absolute value of 9?
9.
Huh, so 45 minus 7. Better be? Check. It worked. Let me check the other one. This is me just checking it. Because, you're taking your final. You have more than enough time. You actually do. Last year, I at least remember, nobody took the whole time. So you have more than enough time. But not everybody checked. Go ahead and check it. Who cares? 5 times. Now, this one's going to be worse to check. 9 minus 5 times 18 over 5. Big ol' bracket. Minus 7. Oh, but look at that. Those 5s aren't nice. See what those two 5s did? Psh, psh. Minus 7. What's 9 minus 18? Oh, shoot. What's the square root? Or, not the square. And now it's the same problem as before. Worked out. Check. Cool. It worked. Had to be careful, but it worked.
That's why I said you're sure of yourself.
Now I am. I wasn't before. So the rule, I guess, is going to be. Here's the rule. Then we never defined the rule before. Can anybody define the? Actually, without me doing it, can anybody define the rule? When you see an absolute value sign. And we didn't just turn it into positive.
We have both two solutions.
So if I got absolute value of x, what do I need to do? Dot, dot, dot. I'm not going to put equals because the equals is kind of messy. Oh, I shouldn't say that. I should say the absolute value of x equals a. Dot, dot, dot. What do I do? A is just a random number in this case.
Absolute value of x are negative x plus or minus
X equals.
plus or minus a.
I'm going to do it in two cases, but yeah, you're right. If you want to think about x equals plus or minus a, you can. But I would think about it in two cases so you don't forget to do two different problems and not try to mess with it. So, sometimes we do like plus or minus in the problem when we do the quadratic formula. This is not that. Don't just carry it. Like, separate it out. Interesting. Good question. All right. Whoops. What else we got? What else we got?
And you treat the absolute value of inequality the same. But that's
No, inequality is different. Ooh. Is that one of these?
that's 17.
Let's do it. Inequality is pretty darn similar.
Wouldn't be just
What?
wouldn't it be just the same thing as was doing like the equals, but then now we have the basically we have the number line and
We do use a number line for this type once we get to here. We do incorporate the number line stuff.
basically intervals.
Oh, and look at that. One of those is super easy. Let's do the one where they didn't give it to us isolated. So let's do B, just because it's the hardest of the three. All right, here we go. 3 greater than or equal to 4. Ideas for the first step? Oh, and we're going to be left with a fraction this whole time? This is not fun, but it's possible. Might not be easy. It's worth it.
Would
Nah.
that answer be plus or minus or minus?
No, but I did forget something super important.
Oh, it absolutely.
You put negative.
Yeah.
Boom. Okay. What do we do when we have this? It was slightly different than the other thing.
You put negative 4 on the other.
You throw a negative of the thing on this side, and then what do you do?
You do it to both sides?
You add the.
You draw the exact same sign facing the same direction. You draw the exact same sign facing the same direction. But now you can get rid of the absolute value. You just have to have the absolute value by itself before you can do that. We had to do the 3 thing first. Had to. No option not to. So now we've got negative 4 over 3, bigger than or less than 2x plus 1, bigger than or equal to 4 over 3. Now what?
So, would we just be
Subtract 1?
divide both sides?
Yeah. No, it's not. Oh, you're just talking about because of fractions? We should be good at getting fractions and subtracting 1 from a fraction. Negative 7 over 3, less than or equal to 2x, less than or equal to 1/3. Good call.
What?
What do you mean what?
How's it 7?
How is it 7 over 3?
Yeah, like how is subtracting 1 by that equals 7?
That's subtracting fractions.
It's the same thing as 3 over 3.
If we have a pizza.
Oh, yeah.
No, listen. No, hey. Shh, shh, shh. If we have a pizza with 3 slices, and I steal 1 from you. No, listen, this is important. No, wait, how many did I steal to start, actually? I stole 4 to start. Red, red, red. Now I've stolen another one. I've stolen 4 slices of 1/3 of a pizza. I have 4 out of 3 pieces. That's what I've done. And then the problem said, guess what I'm going to steal? Another whole pizza. Let's make that pink. 1, 2, 3. There's my whole pizza in pink. I'll do it blue so it's easier to see. 1, 2, 3. Now how many pizzas have I stolen? Well, no, tell me the number.
7 plus.
1, 2, 3. That's terrible to see. 1, 2, 3, 4, 5, 6, 7. Out of. Still, the bottom is just the number of pizza slices. There's your negative 7 out of 3. I stole 4, and then I stole another pizza. If you don't like thinking about it that way, here you go. 4 over 3 minus 1 is the same thing as negative 4 over 3 minus 3 over 3 is negative 7 over 3. If you like adding and subtracting. Well, yeah, of course. That's like nobody. What? Leave it?
Yeah, let me just make sure. So take a little side note.
No, go home and practice subtracting
There's
fractions.
no side note.
Okay, there you go. Then divide by 2, right? Oh, we're going to hate this part.
What do we multiply by a reciprocal again?
Who started?
We can just multiply by 3.
Negative 7 over 6, less than or equal to x, less than or equal to 1 over 6. And then I go to the number line, and we're done. We got x by itself. Actually, no. Don't even be fancy with it. Just put a line and call it negative 7 over 6. And then it's 1 over 6 to the left or the right of that. Yeah, put a line and call it 1 over 6. Now I got to figure out which way to shade.
Towards the right.
X is less than 7 over 6, right?
Negative 7.
So it goes this way?
So it goes to less than, right? And x is greater than 1 over 6. So it goes.
So would that be a
And it's
union
closer.
interval?
And it's a closed bracket because of
Greater than
that symbol right there, right? And technically, if we want to be super technical with it, this would split up into 2 different equations because it is 2 different equations, and we will call it x is less than negative 7 over 6, and x is greater than 1 over 6, just to be safe. And they would say and, usually. But I'm okay with you doing it the other way and working your way to that. There's actually another thing that I don't know that shows up, but it's actually we learned.
interval,
Yeah. Where does this start at?
negative infinity.
And it works its way all the way up until it hits. Union.
like 1/6 plus
Love it. That's such a good problem.
So I know something.
All right, what else are we doing here? Hunt down a problem. I will solve it.
Do you want to radical? Yeah, I don't even do it.
We got one?
What about the
Number 11? Let's check it out. Oh, shoot. Are we doing this? That's tough. That's tough. Who called this one? Who called this one? Here we go. You want to do long division or synthetic division, or don't care?
I feel like synthetic is like.
Well, the first one and the last one you can use synthetic, and the middle one you can't. That's the interesting thing. I mean, I'm happy to do one of each, or you could wait, or you could go home and practice one. I don't mind.
Let's do the one
I don't know which one's like the final, so.
We can do long division.
You can technically do long division for all of them, right? All right. I don't like this. 5K minus 4. Big old thing. Ooh, here's what I'm going to check for all of them, though, even if we're not going to do all three. I am going to do this because I forget this all the time, and it screws me up, and I have to start over. You know what would make you have to start over? Yeah, the 3, 2, 1, 0 thing. 3, 2, 1, 0. Good to go. 3, 2, 1, 0. Good to go. 3, 2, 1, 0. Good. Okay. I have in the past forgotten it and had to start all over in class before it. I was like, oh, what a waste. So that's an important thing to check. It's also worth noting, and though it never happens very often, that you should do it for this side as well. But I've never seen that happen. So we're doing the middle one. 50k cubed plus 10k squared minus 35k minus 7. If it was missing one, what number would we add?
0.
Plus 0 or minus 0. You pick. Doesn't matter. All right, so can 5 go into 50?
Yes.
Not 10.
10k squared.
10k squared times.
We basically
I basically do this. You don't have to do this, but I do this every time. 10k squared, big old parentheses, 5k minus 4, distribute, equals 10. Whoa, that's not true. 50k cubed minus 40k squared. Then I hop over here and write it. 50k cubed minus 40k squared. That's not what we do, though. Big old brackets with the minus sign. And 50 minus 50 is. If it's not 0, you picked the wrong thing. That's okay. Go pick a different thing. It has to be 0, though. It has to match and cancel. If it doesn't match and cancel, you pick the wrong thing. That's okay. Just start over and go pick a different thing. 10 plus 40 is? Why did we plus it? Because a negative distributed to a negative makes it positive, right? Okay.
5k.
Oh, look at that. It's going to be the same, huh?
So when we bring down the negative 35?
Well, yeah, but that's just going to get affected later. Plus 10k this time? I'm going to skip the steps that I said I never skip just for time's sake because we're already at 45. So we'll go 50k squared minus 40k. But that's not what we do. Minus sign. Cancels out. That's good. It should. Distribute plus turns into 5k. Holy crap, that's awesome. But 5k is what I'm saying is awesome. Plus 1, you think? 5k minus 4? But that's not what we do. So we are left with -3 as your remainder. Which means, well, yeah, but what I was going to say is that means that's not a factor. In fully factored form, that's not a factor. That's not a 0. That doesn't tell you a 0 of the solution. That's not a nice factor. That's just a division problem. That's kind of interesting. So yeah, but you're right. What that does mean is we put it to the top, and our answer would be 10k squared plus 10k plus 1 minus 3 divided by 5k minus 4. That's B. Cool. I love math. Oh, yes. Number 9. What?
It's a song for fun.
Oh, cool. Yeah. Oh, I remember these from back in the day.
Oh yeah.
Y'all remember this? Oh, this was a hard one on test 1. It was unpleasant.
I remember you said there was something that could have been done, like braided over.
No, there's nothing to be done that's easy. How do you get rid of square root?
Square both sides.
You just square both sides and go to town. As ugly as this is about to be. Ooh, but the left side's pretty.
7x minus 3.
And the right side, don't be a hero. Don't just jump right into it. What do you have to do to that thing?
Foil it.
Foil it, right? So you get 9. Right? First. Plus
Plus
3 plus another one of those same things, right? The middle two terms are always the same. And then plus what? No, hang on. I'm going to go do that. Sorry. I mean, that's right. I'm just going to not assume that it's easy. Also, if you're not a box method person, that's okay. You don't have to be. You can do FOIL. Just some people like the box. It's the exact same thing. This is first. This is outer. This is inner. This is last. It's the same thing, just pictorially. What's -3? And this is a time sign, right? 9. Negative and a negative make a positive. Can't combine them. Don't even try. Can't combine them. Don't even try. Square root of 8 minus x. Square root of -8 minus x squared, which kills the square root and the negative sign, right? Which is where I got that 8 minus x from. Cool. So let's see if anything combines or cancels.
Yeah, the square root means.
Square roots combine together. Plus 8 minus... Oh, that turns into 17 minus x plus 6. Move those both over, huh? What do you mean, what the heck?
Oh, you get some.
9 plus 8?
Oh.
Move those both over. You get 8x minus 20. Full disclosure, I made these numbers up. That's why they're ugly. Divide by 6. Divide by 6. You get 8x minus 20 over 6, which is reducible for sure. I'm going to reduce that real quick. That's freaking 4x minus, not 5, 10 over 3. Divided everything by 2. Equals, how do you get rid of square root? Oh, man. This is a go home and practice so you make sure you know how to do it. I'm not leaving it. I'm finishing this problem. Square this, square the top, and you end up with 16x squared minus 80x plus 100 over 9 equals 8 minus x. What? Actually, that is a long problem. What did we do wrong? No, I did something messed up. No, I didn't do anything messed up. I just should have not made up terrible numbers. This is fine. Now what do I do with those two numbers on the right side? Move them over. Okay, this is where it's not pretty and it won't happen on the test. You should get 16 x squared over 9 minus 80 x over 9 plus 100 over 9 minus 8 plus x equals 0, right? So we should get 16x squared over 9 minus 71. Because this is technically 9 over 9x, right? Plus, which is 72 over 8. Nope, 72 over 9, right? So what's 100 minus 72? Over 9? And now what do you do? No, don't do AC method. Negative b plus or minus the square root of b squared minus 4ac all over 2a with a, b, and c. On the test, it will be an easy factor with 1s and 2s and 3s. It won't be those fractions. But 100%, I just made these numbers up. It'll be this type of problem. Same steps. Just I literally made these numbers up and didn't realize that what that meant for us. Oh, absolutely. And I'm posting this too. But that's funny. That's right. No, that's right. That's just freaking... I forgot that we had to do the factoring thing at the end. You can do it. You have the skills to do it. It's just unpleasant with fractions. Nobody likes fractions. I'm going to solve the radical equation. I'm going to find one that's solve the radical equations. I'm going to find one that works out perfectly with easy factors at the end. And I'm going to write it down and then have it posted. Okay, here's these all only have a square root on one side, but I really need one that has a square root on both sides. Haha, I found one. This one will easy factor, promise. I'm going to write it down. I should have done this when I was making the review. I just made those numbers up. Doesn't mean it's not possible. Just means it's a lot less fun. If you want to go home and practice that one, and then come back, and if you don't get it, we can work it on Thursday. Come back and ask on Thursday about these 2 or 3. These all are of the same format, but I'm looking at them and they only come up with one answer, not like a crazy fraction answer. There we go. This is some practice with nice numbers. Same exact steps, so you can go watch this video. Same exact steps. Square it, move it over, re-square it again after you FOIL. But those ones will turn into 1s, 2s, and 5s and not crazy fractions. I should have just done that. Come on Thursday if those are still too tough, and we'll do one more of them. Okay. Let's find one more or 2 more. We got 15 minutes. What are we thinking?
Can you do 15A?
15A. Oh, sweet. Yes. I say that about every problem, but as soon as I see them, I'm like, yeah, that looks fun. So I actually mean it. I'm not just like saying it. Genuinely excited about solving this problem. You got any ideas while I'm scrolling down of the like key term that goes with this problem? It has 3.
LCD.
Yeah. That's it. LCD, which stands for not a TV screen. Least common denominator. But the key thing there is, even if you forget the word lowest, you can still solve it. Common denominator is what matters. If you multiply them all by 100 on the bottom, it still is going to work. You're just going to make a bigger problem for you. It's okay to do a common denominator that's bigger. Least just makes your life the easiest. Okay. One step at a time. Don't try to do it all at once. Go one step at a time. What's the common number? No, I said one step at a time. What's the common number? Let's not even solve it. Let's just look for that LCD. Okay, the number part of it is probably going to be 6, right? Which means this is the only thing keeping us there. So we're probably going to multiply that thing by 3. Maybe. All right, what about the variable? X squared, not x. X squared, which means we're probably that middle thing's the only thing keeping us from it too, right? So really, this middle thing's the only troublemaker. So I'm going to rewrite the first thing. I'm going to rewrite the second thing, and I'm going to leave some room. I'm going to leave some space for me in the middle. And I'm going to hop over and rewrite the third thing. And you know what that space is for? Multiplying by something to get my least common denominator. I can't just go willy-nilly multiplying by numbers. You can't go willy-nilly multiplying by 3x. You can go willy-nilly multiplying by 1. Right? You can multiply things by 1. And then you can write 1 in a different way. Right, 6. If I multiply by 6x squared, it's going to give me 12x cubed. That's not our least LCD. Which was actually 6x squared. Sorry, I should have written that. Hey. Can we go just lackadaisical and multiply by that everywhere? Yeah. Technically, we did the same thing here, didn't we? You know what we just did, though, before we did it? Canceled them out. Technically, we also did it here. You know what we did? We just canceled it out. The only thing is here, we're not going to cancel it out. Here, we're going to use them to our benefit. So it's not even like we broke the rule of what you do to one side, you have to do to the other. We did it. We just used it in a weird way. We did it. We just made it 1 right here and multiplied and we're done, right? So we didn't break any rule. We didn't make up a new rule of like, oh, you can just multiply by 1 randomly. No, we multiplied across the board by 1. Just only in one spot did we make it work in our favor, right here. So this stays the same. 3x times 1 is that. Oh, look at what happens on the dang bottom. And you know it's good because in your brain, Yeah, pretty much, right? And you know it's good because in your brain, what you can do is you can just zoom into the thing you changed. If you were to, if that were a problem standalone, if that were a problem standalone on a test, what would you do? You'd go like this, right? Psh, 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 psh. Oh, we didn't change anything. It is that still. We didn't change anything. It still is that thing. If that were a standalone problem on a test, we didn't multiply by a thing to change it. We just rewrote it in a weird way that helps us. So now we got 1 equals 3x plus 7 over 6x. Now, you are right about that top thing, but before I do, I need to make a little note just for my brain. It's not going to come into play this time, but maybe it would someday. What's the note my brain's making? Before I get rid of this, before I do what you said, which is just set the top equal to each other, I have to make a note in my brain about this problem. No, it's going. We are throwing it out. Because watch this. Times 6x squared. We are throwing it out. Right? We're going to do that. But I had to make a note while I did that. There's a note. Let me zoom out real quick so you can look at the beginning problem too. There's one just note I got to make to see if it comes into play later.
Is it where it's like not equal?
Is it that?
Something. Yeah, it's just very some. What do you keep going down that train?
Must not, the denominator should, the x should not be 0.
X. Well, the denominator should be 0, which in this case means
Yeah.
x better not be 0. So my note is x better not be 0. Right? Right? If x is 0, bad.
And undefined.
Also bad right here. Triple bad. If x is 0 at the very top, triple bad. Now, is that going to actually affect anything? No. Because we're about to solve for x and see it's 1/3 or so. I don't actually know. 7 over 3. Negative 7 over 3, something like that. Who knows? That was wrong. I don't know what it is. We're about to find out.
It's 6. Negative 6.
1 equals 3x plus 7. Negative 6 equals 3x. X equals negative 2. Right? Right? So did that actually matter? Did my note matter? But if I would have solved it and got x equals 0, no solution. No solution. Not 0 is a solution, no solution, because it broke my only rule, which was the bottom better not be 0. Let's check it and see, though. Negative 2 squared is 4. 4 times 6 is 24. Good to go. 1 over 4. 7 over 24. 1 over 4 plus 7 over 24 is 6 plus 7. Wait, I don't know what I'm doing. Plug it in and check. Hang it.
You just say negative 2 times 8 is negative 4.
But yeah, but what I'm saying is plug it in and check. Don't be content with your answer. You have plenty of time. 1 over 6 times negative 2 squared equals 1 over 2 times negative 2 plus 7 over 6 times negative 2 squared, 1 over 24, right? Equals 1 over negative 4 plus 7 over 24, right? 1 over 24 equals negative 6 over 24 plus 7 over 20. Hey! Check. Always check. I didn't say that before because our tests were an hour. Now I'm saying check because your test is 2 hours. And multiple choice.
We have an
To graph? If you do the multiple choice questions, we'll have little graphs on them for you to pick.
Oh.
Which is kind of nice. Like if it's an asymptote thing, like those little asymptote things where they put it at when the bottom's equal to 0, just look at your graphs and be like, that one has the bottom things that match the vertical lines. That kind of thing. We don't have time for 1, maybe 2 more. Inverse?
Oh.
Yeah, also if anybody else has one. Thank you. I appreciate it.
I very much appreciate the whole paper being looked over, but I'm not sure what you look at.
What was that answer? We'll do an inverse real quick. I like inverses. They're fun. I'm not going to do B. B seems way too easy. Let's do A, I guess. There were 4 steps for the inverse that you don't have to remember. You can just remember the one middle step and be good. But the 4 steps were 1.
Change f of x to y.
Oh, you remember that. 2,
Switch both bases in x and y.
3,
Solve for y.
4.
Basically, the root is not y.
No.
No,
With that little negative 1 up top.
f inverse.
So I'll do the first one. Y. Well, no. H of x equals root 3x minus 3. Y equals root 3x minus 3. X equals root 3y minus 3. Solve. Plus 3. Plus 3. X plus 3 equals root 3y. Ooh, how do you get rid of root 3? That's a...
Basically, multiply.
Cube both sides.
Both sides.
And then we switch them back. So f inverse of x equals x plus 3 cubed, which if we want to simplify it can just be x cubed plus 27, right?
What?
Wait, that's not right.
Thank you.
No, wait.
It'd be x times 2.
Don't just agree with that, right? No.
No, yeah.
You
that doesn't
can't-
make sense.
You cannot do that. Bad, 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 bad. Do not jump. Do not even be tempted. Actually, leave it here. Don't be tempted to do anything. Leave it there.
We all don't have something like the x squared.
It has like 6 terms, right?
2ab plus.
I know it would start with x cubed, and I know it would end with 27.
Yeah.
I don't know what's in the middle. I'd have to do it to find out. I'm pretty sure that's how it writes it when it does multiple choice on your test. I saw that.
This is still
All right, 5 minutes. We can do one more. We can do a single more. And then, like I said, you are literally more than welcome to stay till 8, and you are more than welcome to come back for the whole 4 hour or 2 hours on Thursday as well. That's 4 hours of review.
definitely do that Thursday.
More than welcome. I don't mind at all.
Can we do 31?
31. Sounds like a hard one based on how far down it is. Domain. Oh, shoot. Wait, that's super important. Because that has a little hiccup. The domain of a composite has one little hiccup. Okay. That's interesting that that's on here. That's tough. That's harder than just a normal domain. But let's do 2 normal. Let's pretend like it's normal domain just in case you see a normal domain, and then we'll pretend like it's a composite. So let's pretend like this is just 2 separate problems. So what is the domain of f of x, unrelated to anything, f of x? What's the domain?
Let's say any number.
Is there any bad things there? No.
Any real number.
So we call it all real numbers or all real numbers. That's good. Actually, let's make this note too. I know, I'm sorry, I'm going on all these tangents, but it's important. There's only 3 things that make something bad.
Zero on the denominator.
A number over 0,
Negative is right square root.
a negative number in here, and the third thing was more recent.
Log of 0 or log of negative.
Log of 0, log of negative number, which actually includes the ln as well,
Yeah.
right? These are bad. So I shouldn't actually write these as good things. These are all bad. These are all things that kill your domain or restrict your domain. Do we have any of that happening in the first one?
No.
Heck no. What about the second one?
Yeah.
Yeah. That stuff inside the domain, which I'm just going to write right here, better be something. It better be this stuff right here better be what?
Better be greater than 0.
It better be bigger than 0, or can it be 0?
Yes. No. Yeah.
Square root, yes. ln, no. Right? Square root, yes. Logs and ln's, no. And then you just solve. Normal style solve. Negative x squared greater than or equal to negative 9. Divide by negative 1. Divide by...
Wouldn't that basically give us x squared greater than?
Divide by a negative means you do what?
Keep the sign.
That was like one random rule that only happens in that one time ever. And that means that x is less than or equal to
Oh, plus or minus.
the root of 9, which is plus or minus 3. That's so odd. X is less than plus 3 and less than minus 3. That's not right. That's not right. One of those is flipped. X is less than or equal to 3, and x is less than or equal to... We have to flip the sign again for negative 3 because it's a negative sign going across the thing. Because when we did a square root here, we sent a negative division across the thing. But let's just check and make sure. Don't be safe with it. If this is our domain restriction, let's check and make sure. Plug in 0. That's in the middle. Can x be 0? No, stop. Just ask yourself this question. Can x be 0?
Yes.
Square root of 9 is good. Can x be 4? No, that'd be 9 minus 16. Can x be negative 4?
Yeah.
Yes.
Ooh.
No.
9 plus 16 is 25. 25 square root of 25 is...
It wouldn't be plus, though. What's negative 4 squared?
That's
16.
9 minus 16. Bad, right? So the domain for g of x, I know this is a separate problem. The domain for g of x was from negative 3 to 3, right? And it looks like that. That was the domain for g of x.
But wouldn't those be like brackets slash?
Oh, good call. My bad. Thank you. Because we have that sign right there. Boom, 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 boom. Very good fix. Very, very good fix. Okay, but this is not composite. This is not even the problem. The problem is compose those two, right?
Yeah.
So f of g of x is
Plug in
root 9 minus x squared
plus 3.
plus 3. Okay, so
Tell me we're still of g of x would still affect.
okay, so here's what you say for the domain. Right. Here's what you say. G of x domain still matters. And you know what the other domain matters? The f of g of x domain matters. You know what domain doesn't matter? F of x by itself does not matter. So in math words, what we can write is the domain of g of x united with... I don't know how to write domain of g of x without writing domain of g of x. Is there a way to write d domain? Oh, it's DOM. That's right. This is how it was written in the book. Domain of g of x united with the domain of f of g of x. That's how they wrote it with that. Is the domain of f of g of x. And in this case, I know it's fast. We can go over it again on Thursday. I'd be out to review. But where's the bad numbers here? Same exact spots. It didn't change. The only bad numbers inside that square root, right? So your domain for f of g of x, I know we're leaving, is negative 3 to 3, just like it was for g of x. Because you got to check both of those.
No, you would plug in g of x, plug in x plus 3 and x squared. Man, I'm tired.
I'll let y'all pick. You can work a few. You can work with the partner silently if you want to for a little bit. and then ask questions. You can just, if you know what you want to work already, we can start. I'm happy to do whatever. I'm not just gonna start at 1 and go through it. I need you to actually pull it up on your computer or phone and know what you're asking. Actually, I don't even want you to see it. I want you to be responsible for pulling it up and knowing. Because otherwise you're just gonna ask me the one that you see on the board. And that's not helpful. I'd rather you know what you're asking and know what you need help with. Know what you don't know is way better than Good question. I just learned that yesterday after class. I need to send this email out. We'll be in Dillon 1, which is the big, like, that hall, maybe. I don't know. It's like a big room because all the college algebra takes it at the same time together. So it's like this big auditorium over in the main room. I will send an email out with that. Thanks for asking. Dillon 1 is where it is. I'll write it right here too. If you want to write it on your board, it's called Dillon 1. It's that building, the big one with the main-looking one. I don't know. You know what I'm talking about? The main-looking one. What? Hinton. But if you go in the doors and then walk straight through, it's the last door on your left before you go back outside. Left. Right? On the right, there's that, like, boardroom. On the right, there's, like, that meeting room thing that's just for small people, for a small number of people. And on the left, there's the big meeting room. If you're coming from the other side, it's on the right when you walk in. Or you just look for that number. Nine? Okay. Okay. Wait, are these the square root ones? Okay, honestly, here, let's do this. I went on, we did one last class period, and I made those numbers up, and they're solvable, but they do give you fractions, and then you have to plug those fractions into the quadratic formula, which is unpleasant. So I went online, and let's do this real quick. Here's 3 ones that I wrote these down. I said, hey, for number 9, here's 3 practice problems that I know will give you nice, neat numbers. Try those first. So I'll come back to 9 in like 3 problems. But if you want to not pay attention and try that because that's the only one you didn't know how to do, there's 3 that are super solvable. But if you want to see the work for the ones that are on the board, there I'll post. I already posted a video and I'll post these notes. That's the work for the ones that are there. It just ended in ugly fractions, which is fine. You can do fractions. The test probably won't have that ugly fractions, but you can still do them. But those 3 for sure are no fraction answers. Yeah. And then I will come back to 9. I want to do it, but I wanted you to know if you got ugly numbers, that's because I made those up. Those 3 are book problems that we ran into that problem last class period not knowing. You said 24C? Okay. Oh, sweet. That one's awesome. Okay. 24C. All right, so there's a... Man, this would be great if it didn't have that 4 right there. It would be like done if you didn't have that 4 right there, right? Okay. So what this comes down to is, do I remember one special rule for these things? So you know how to get rid of the E, right? That's like, we're done. Getting rid of the E is easy. So you ln something, right? We're going to ln the left side. Likewise, we're going to ln the right side, ugly as it may be. Because then we catch that special rule like right off the bat. You remember that rule? The multiplying, whoa, that was bad spots, but that. There's a multiplying rule, right? There's a multiplication right there, and multiplying has a rule. Anybody remember that rule? It's addition, but on the outside. But yes. So, this one actually gets reduced nicely already. Can we go ahead and do that one? Those cancel out, right? So x plus 1 equals ln of 4 plus ln of e 3x plus 1. Oh, shoot, those cancel out too, don't they? So now we got x plus 1 equals ln of 4 plus 3x plus 1. From there, it's pretty doable, huh? Yeah. But I'll keep going. Let's see. I'm going to move it to the left side just because sometimes I do that when it's easier to do. So minus x. Move everything else over. Oh, look at that minus 1. That's cool. Wait, this is a cool problem because of that. So now I've got negative ln of 4 equals 2x. So x equals negative ln of 4 over 2. It's kind of fun. You want to get even crazier with this thing? What?
Is it okay if you, the first step, if you divide the whole equation by e on 3x plus 1, and then you would subtract the exponents on one side and then just ln it? That's how I do it.
Did you get the same thing?
I don't know why.
Wait. Then talk me through what you were saying again. I'm listening. Divide the whole thing by what?
Can you go upstairs? Like divide both sides by e on 3x plus 1. So both sides.
Well, oh, got it.
And then I would-
From the start. I thought you were talking about from right here. Yes, got you. Actually, that's pretty cool, huh? Let's see if we get the same thing. I'm okay with this. This is a fun thing. He said, let's take it from the beginning and divide by e 3x plus 1. So that would start us out with e x plus 1 divided by e 3x plus 1 equals 4. Okay. So then you're going to ln both sides?
No, now I would just
What?
subtract the exponents.
Oh, exponential subtraction. So e x plus 1 minus 3x plus 1.
Yeah.
So e negative 2x equals 4.
Yeah.
And then you would ln both sides. And you'd get negative 2x equals ln of 4. And then you divide by negative 2. Oh, look at that. So the same thing, right? Wait. Why did I do that?
Instead of an x.
Incorrectly or correctly? Oh, incorrectly. I don't know where that x came from. That's cool. That was fun. I like that. Here's another thing. Can we go a step farther and say this is actually x equals negative 1/2 times ln of 4? Anybody see it yet? Anybody see it? It's really cool. What do you see? There's a special rule for this thing.
Oh, there's 2
ln of 4 raised to the negative 1/2. What is 4 to the negative 1/2? Right? Because that's ln of 4. Well, wait. Ln of 1 over 4 to the 1/2, which is ln of 1 over root 4, which is ln of 1 over 2. Guys, that's so cool. Look at how simple that problem ended up being. Or not simple. Look at how reduced that problem ended up getting from the beginning.
So is ln 4 over negative 2 not the answer? Or was it
They're the same. But what I'm saying is you might have a multiple choice test. And I know everybody would be freaking mad if you got to negative ln of 4 over 2, but the answer was that one. They don't look the same, right? But they are the same. So that's why I wanted to show you both ways. I honestly don't know. I haven't looked at, when I looked at the problems on the test, I didn't look at also the multiple choice answers and see what form they're in. But those are the same thing. Okay, what else? 19b. Oh man, absolute value. Boom. All right, so there's got to be a rule for the absolute value before we even get started. Because if that absolute value weren't there, you wouldn't be asking this question, right? It would just, I mean, it still might be hard, but it'd just be moving, dividing, moving, right? Okay, so there's got to be a rule for this absolute value that makes this problem slightly more harder than it should be. So what is that rule before we even get jumping into this thing? What is the rule for absolute value? Well, that's for every problem, right? That's a good way to say it, but that doesn't help us know what to do, right? It is always positive. So what does that mean it does to the equation is the thing I want to try to figure out before getting started. Because I can tell you what to do, but I've already done that. It turns it opposite. So let's think about this. What's the absolute value of 4? Okay. What's the absolute value of negative 4? So what was the rule? What was the rule there? Or is there a generic way to say that without a 4? Because 4 doesn't help us. Is there a generic way to say that thing? Well, that's true. But in math words and not English words. That's where it gets harder. How do you say anything in math words? Here's how you say anything in math words. X. That's anything, right? X means anything. So when you said the absolute value of anything is positive, that's anything. That could be 1, it could be 0, it could be 1,000,000. The absolute value of anything is itself, right? When we throw this plus or minus here to prove the absolute value of plus or minus x is x. That's going to help us in a second. That's going to help us a lot in a second. Okay, so here we go. B, because it has that extra thing on the side. A is a little too easy. So before we do anything, let's do the things that we know to do, or not know to do, but we could do. Let's do the things that are like obvious. Like if this absolute value weren't here, we would add 7, right? Please do. If that absolute value weren't there, we'd be adding 7. If that was all one big x, 5x minus 7, we'd be adding that 7 first, I hope. 5, absolute value of 9 minus 5 in bracket equals, I'm bad at math, 42, 45. 45? Oh, look at them teeing us up for a curve, or not a curve ball, but a slow ball. Boop. 45 divided by 5 is 9. Now we've got a choice to make. What do we do with its absolute value? And here's what we're going to do. We are going to make it 2 problems. Once you get absolute value by itself, make it 2 problems. Ready for this? 9 minus 5n equals 9. But also, 9 minus 5n equals, what do you think? Negative 9. That's it. That's the whole step. That's the absolute value step. But you still have to do the normal math stuff. You know, the like draw a line, solve both sides. Negative 5n equals 0. N equals 0. Psh, 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 psh. Negative 5n equals... Wait, that was wrong. No, that was right. Negative 18. N equals 18 over 5. But don't trust yourself. You know what you can do with those 2 numbers? Plug it in to make sure it's right. And you have more than enough on your test. I haven't had anybody on their final take so long that they didn't have time. Just take that 0 and plug it in. 9 minus 0 is 9. Times 5 is 45. Minus 7 is 38. It worked. Plug the other one in. It works too. absolute values. HC? No. Yeah, we will. That's terrible. Find a rational zero. Just one. Well, this is cool. We can hit two birds with one stone. Because I remember another problem on the test for sure is find all possible rational zeros, so we can just do two birds, one stone with this thing. All right? So, let's do the other bird that's not this bird first. One bird, one stone. If it said find all possible rational zeros, there's a special way, or not special, but there's a way to do that. You know what you do? We're doing C this time. This is important. You take this number, which we often call the trailing coefficient or the trailing constant. And you take this number, which we call the leading constant, and you divide them. But that's not your answer. That would be dope if that was your answer. That would make life easy. What do you do with those things? You find every single factor of them. So what are the factors of 18? One's a great start. Plus or minus 1, 2, 3, 6. I wrote 8, but I meant 9. And 18. And what are the factors of 2? 1 and 2. Okay, so this is going to be annoying, but I'm going to do it just so we can see it. I'm not solving them all. I'm just going to write them all in a list because on the test, they're written in a list, in a long list so you can see it. And the list starts with these open brackets, and it just starts on the first one and the first one. So -1, +1. Check. -2, +2. Check. -3, +3. Check. -4, +4. Whoa, what? There's no 4. -6, +6. Check. -9, +9. Check. -18, +18. Check. But that's only half of them. You know what the other half is? That's only the ones that are over 1. Check the one on the bottom. Now we have to do the exact same thing divided by 2 for this blue check right there. So, +1/2, -1/2. Check. +2/2, -2/2. Wait. 2/2 reduces to what? 1/1, which is just 1, which is already written, so you don't have to write it. So I'm going to leave them there, and I'm just going to cross them out because they don't actually exist, because they're already taken care of right there. -3/2, +3/2. That's not written anywhere else. -6/2, +6/2. Is that written somewhere else already? Right there, right? So you actually, that's not going to show up whenever you're taking your test and trying to answer these questions. That's not going to show up on the list because that's already taken care of with that 3. So it's like, oh, I don't see that. Well, that's because it's there already. -9/2, +9/2, and -18/2, +18/2. Is that written already? Yes, it's taken care of in the 9s, so that also won't be there. So your list will actually be like 6 shorter than you would think it should be. When I first started this problem, I thought it should be that many? Twice. But I was wrong because we're missing 6 problems. 6 of the ones that I thought. because they showed up twice. They doubled up. 6 over 2 is the same thing as 3 over 1. So we're not going to write it twice. Okay, but that's not, we're never going to use that. We're only ever going to do like the first 2 or 3 and see if it works, right? So, by golly, I don't want to do this, but we will. Which one do you want to start with? Make a good guess so we don't have to do this a bunch of times. 1, I guess. You're going to start with 1? I don't know. I honestly don't know what it's going to be. So, yeah, we'll just start with 1 and see what happens. So we write 1 on the outside, backwards L, and we take the coefficients of 2, 5, 16, 5, and 18. Was anything skipped? 4, 3, 2, 1, 0. No skips. That's good. So then down here, we're just going to go 1 outside of 2. Negative 5. Negative 16. Negative 5. Negative 18. Drop down the 2. 2. Negative 3. Negative 3. Bad at math. Negative 19. Negative 19. Holy moly, this is going downhill quickly. Negative 24. Negative 24. Negative big number, right? Negative 30. Negative 42. That's not 0. That's not our answer. And you know what? Just based on all the negatives that we started snowballing, I'm going to try negative 1 next. Just to see what happens. So negative 1, bracket, 2, negative 5, negative 16, negative 5, negative 18. Drop it down. 2 times negative 1 is negative 2, negative 7, positive 7. Frick. 9? Is it? Negative 9, positive 9, 4, negative 4? Nope. Gosh dang it. Somebody else start trying the other ones that I'm not doing, and let's see if we can find one. Wait, what if this doesn't even have one? What if I just made this number up? Surely. Did you try it already? What? How do you know? Did you Google it? Mathway? Mathway? Ah, fine. Do you know the number to try? Save us all problem. I'll try 2 next. No, I'm trying negative 2 actually. I just have a hankering it's going to be a negative number. Let me know if you get it and I'm doing the wrong one. Oh, sweet. 2, negative 5, negative 16, negative 5, negative 18. Drop it down. Negative 4, negative 9, positive 18, 2, negative 4, negative 9. Hey-o. Positive 18. 0, check. X minus factor is x plus 2. 0 for that factor is x equals negative 2. X-intercept is negative 2 comma 0. Lots of steps to get one little x-intercept. And you can keep going. We could backfill in that thing, but that's not what the question asked us this time. But we start with a 4, so then we go x3, x2, x1. And you could keep doing this over and over again. But we'll stop there because that's where it stopped. And for the sake of time. Wait, what? Uh-huh.
That's all the answers it could be.
No, the blue ones it could be blues too.
Yeah, I'm saying so can we just technically guess
Off the reds?
off the blues?
Yeah, but that's way harder. Wait.
I'm saying like if we look at our answer choices and then we see that
Oh, you're saying we're gonna finagle this thing. Yeah. If you want to, yes, 100%. I see what you're saying. If you want to finagle this thing and say which one of these has answer choices, but also the question here might not be what are all of them. The question might be here's 4 numbers. Which one's a 0? I think that's what this type of problem was. Is here's 4 things. Which one of these 4 is a 0? Oh, and by golly, if that's the question, you're not going to do any of this. You know what you're going to do? Holy crap, watch this. If you're taking a multiple choice test, this is important. This is more important than everything we just did. If you didn't listen to anything else we did. If you're taking a multiple choice test, and it says which of these 4 multiple choice answers is a 0, you know what you're going to do? What? Yeah, because it's not going to give you 3, right? It's just going to be one equation, and it's going to say, here's 4 numbers. Which one's a 0? You know what you do with those 4 numbers? You plug them in. And you know what you want it to equal? 0. Because that's the 0. That's what it's called. So, like, yeah, the trailing coefficient, leading coefficient thing is good, but if it just gives you x values and says x equals 2, is this a 0? Just plug it in and see if it equals 0. Granted, that one has a to the 4th power, so that's kind of hard, but I don't know. I think plugging in is easier than doing all that. Yeah, I would do that. All right, what else?
What does relative extrema mean?
Minimums and maximums local. Which one has that?
Number 3.
What?
Number 3.
What? Oh, but these are all parabolas. So what does that mean? That's fun. I like that wording. What does that mean? Min/max. And how do you find a minimum maximum of a parabola? You find the vertex. And how do you find the vertex of a parabola? I don't know why I'm doing this up here. I should be doing it lower, but it's not like that. It is that. Yeah, it is negative b over 2a, and that's all you do right there. And then you're pretty much done. So if you get this type of problem where it says vertex or it says relative extrema, minimum maximum parabola, let's just grab this hardest one. B looks the hardest. Negative b over 2a equals negative 36 over 2 times 2 equals negative 36 over 4 equals negative 9. Wait, that's not a vertex. What is that? That's not a vertex. That's just a number. So, but what is that? If you're going to say that in words, what? That's the x coordinate of a vertex, right? And then you just plug it straight in, right? Oh, this one's going to be so bad. Oh, no. Oh, no. 2 times negative 9 squared plus 36 times negative 9 plus 170. I'm so sorry. It won't be that hard on the test. I just made these numbers up. 2 times 81 minus 3. What's 27 plus 5? 32. I don't know. Just do. Anybody know? No calculators. We're not doing that. 162 minus 324 plus 170. 162 plus 170 ends in a 2. Then it has a 3. Oh, look at that. 8. Really? That's fun. So negative 9 comma 8 is your vertex? No? Oh, did I do the math bad? Well, what did I do wrong then? Are you sure? Well, I could have messed negative b over 2a. Negative 36 over 2. No, it should be negative 9. That doesn't mean I did all that little arithmetic right, but go slower on your test. I did that super duper fast.
2 times 81 plus 36 times negative 9 plus 170. Oh, it is 8. Hey.
Okay. 11b.
We didn't do that.
Yet. Cool. It's the long division, huh? Because it has that extra number in the front. Let's say we just did a synthetic division, kind of. We did like 1 or 2 synthetics. But okay. First thing we got to do is check. 3, 2, 1, 0. Good to go. If it's missing something, then you got to add that in there with the 0, right? You got to add plus 0x, minus 0x, whatever it's missing. So now we just jump right to it and go 5k minus 4, big old division sign. 50k cubed plus 10k squared minus 35k minus 7. Oh, about to die.
Any ideas as to what number might work?
So what are we going to do to divide these two things?
Well, frick. We got to know how to do this.
I definitely see a 10 happening, right? Because 5 times 10 is 50. And then to get from k to k cubed, throw k squared up there. And then I always hop over to the side right here, and I just do that problem. Like I literally just take it over to the side, and I'm like, 5k minus 4 times 10k squared equals, do your little distribution thing, 50k cubed minus 40k squared. Hop over here and write it underneath your thing. 50k cubed minus 40k squared. And then what do we do with all that stuff? We've got to remember to subtract it. It has to be subtracted so that those cancel out and make 0, which is what we wanted. Which means that these turn into positive 50k squared. Look at that. Drop this down, negative 35k, and we start the whole process over. 5k times what will give me 50k squared? This time it's just a 10k. So, sake of time, I'll just go ahead and multiply it right here. We'll go 50k squared minus 40k. But that's not what we're doing. We got to subtract the whole dang thing. We're not just adding it, we're subtracting it. Cancels out, goes to 0, turns into a positive. Left with 5k. Drop down your negative 7. Almost done. How many times does 5k go into 5? 1 time. 5k minus 4. Subtract all of it. Subtraction. Plus it. You end up with a negative 3 as a remainder. Holy moly. We don't like remainders. So we just write it with our answer. 10k squared plus 10k plus 1 minus 3. But instead of just writing the minus 3, you know what we divided by? That original thing that we started with. And you call it a day. We'll leave that for a second. Yeah. Yeah, let me leave this for a second for a couple people writing. 25B. What type of problem is it? ARC. Sweet. Good. Okay. What will you say the number again? Cool. This is just can't, and like some of them they give you the formula. This one they don't give you the formula. Sucks. So you have to remember the formula all by your lonesome. Remember the formula? Well, yes, but some people say f of x2 minus f of x1 over x2 minus x1. Some people say y2 minus y1 over x2 minus x1. Some people say change in y over change in x. Some people say slope. It's kind of all the same. Well, the bottom's the easy part. Oh, wait, they don't say x2 and x1, so we got to pick it. Let's just go in order. 1, 2. So we've got x1 equals 1, x2 equals 10. Oh, this is kind of silly of them. Hoping they give us nice numbers. They should have given us like 4. 4 would have been nice. So what is f of x1? That's f of 1. So square root of 4 times 1, which is 2. And f of x2 is f of 10, which is root 4 times 10, which is root 40, which is 2 root 10. Oh, well, at least the 2 will factor out in a second. So now we'll go 2 root 10 minus 2 over 10 minus 1, which is just, actually, screw it. I'm just going to leave it alone. Over 9. If you, yeah. You can't, I cannot do anything else. I don't. Roots can't combine with not roots, and 2s can't combine with 9s. The only other thing you can maybe do, which, heck, if it shows up, cool. If it doesn't, no big deal, is take that 2 out and be left with 10 minus 1 over 9. That's the only other thing you could do. It's not simpler. It didn't cancel anything out. So that equation, yes. The other weird one for quadratic, yes. You should, yeah. The one that they definitely give you is the one that's called the difference quotient, which was that hard one, which looks like x minus h minus f of x over h. They give you that one in the question where they ask you that one. That one? Yeah, dang it. Just the hard ones. Do you know the number? Thanks. I did A earlier, so I'm going to do B. Because it does in that cube. Might be a little weird. I don't actually know what's about to happen with it. But we'll find out. Actually, no. I'm doing the square. I changed my mind again. Because I do know what's going to happen. The cube will make us do a FOIL twice. Okay. I think I did A. I don't remember which one I did earlier. It doesn't matter. So we're going to treat this as like 3 separate problems. 3 completely different problems. We've got problem that's red, problem that's blue, problem that's green. This is just the easiest way to do this so you don't mess up or accidentally run the wrong problems together. So red problem, and I just do them completely separate. So I'm going to do this first one. So if f of x equals x squared plus 6x minus 2, then what does f of x plus h equal? This is the hard part. Hardest part of the whole problem is this step right here.
Plug in 2x plus x into the x.
What are we plugging into the x's? What are we plugging into the x's? Everybody would know what to do if I did this. What's f of 1? What would you do? Plug in 1? So what do we plug in? As ugly as it is, that's all you do right there. As ugly as it is. Everybody would have been completely happy if I put a 1 there. I would have said 1 squared plus 6 times 1 minus 2, right? It's not different, it's just uglier. We just plugged in x plus h where we saw x. And then we're going to see what happens. This is not part of the problem. This is like an example. We're going to see what happens if we work that out. Probably x squared plus 2xh plus h squared plus 6x plus 6h minus 2. Any of those reduce, reuse, recycle? X squared, no. They're all alone. Red problem done. Red problem's the hardest problem. Blue problem's a little easier. What's f of x? For blue problem, what's f of x? It's just a thing, right? Good call. 6x minus 2 is what you're finished. And then what's h? Green problem. It's not a trick question at all. It's just h. So now if we take this whole thing and say, what is red problem minus blue problem divided by green problem, and we get all of this crap, put it in some big old parentheses, minus all of this crap. Whoops, don't do that. Put it in some big blue parentheses, divided by h. Looks like an L. Now does anything cancel? Let's find out. Negative sign. Different color. Negative sign. I don't like that at all. Hang on. Negative sign. Positive sign. Anything cancel here? You're saying negative 2 and positive 2? What about the x squareds? X squared and negative x squared? Negative 6x and positive 6x? So we're left with 2xh plus h squared plus 6h over h. Anything cancel there? H, and just one of these h's, right? Not both of them, because there's only one to cancel with. 2x plus h plus 6. Zoom out for a second. I'll leave it there for a little bit, because that is a long problem. Understood. But it's going to show up. It is going to show up. Sure thing. freeze this while I go get it. Five A. We just did one like that. 5A? Wait, what? We literally just did this problem already. Uh-huh. Well, no, but I said we're going to knock 2 birds with 1 stone out and do one like it. I'm so disappointed in you. It's okay. Find all possible rational. I'm not actually disappointed in you. That was me. Find all possible rational zeros. How do we do that? Oh, no, you're making it way too hard. How do you find all possible rational zeros? Not all zeros. It doesn't ask you for all zeros. It asks you for all possible rational zeros. Dude, this is an important phrase. TCLC. So what's your TC? -2. There's your TC. What's your LC? Oh no, now I've done it. Oh no. The -2 is never going away. Oh no, I'm frozen. I'm super frozen. Please no. No. What do I do? Oh, it won't even close. This is so unfortunate. HBU final exam schedule 2022 fall. Enter. Google first link. It'll be there. It's based on the time of each class. All right, let's see if this works now. Wait, what are we doing? Test 3 review? No. Thank you. Please still have all the notes. Oh, thank the Lord. What? Oh, that's why. What? Oh, okay. TC over LC. Sorry for the delay. So that's going to be -2 over 1, you said? Which is going to be what? Does the factors of -2? And what are the factors of 1? And so that makes this set of what? -2, -1, 1 and 2. Right? Mm-hmm.
But then I tried.
No. It didn't say. It did not say find all zeros. What did it say? Find all possible rational zeros. You tried all 4 of those things long.
Yeah, none of them.
So what does that mean?
No zero. No rational.
Yeah, that means it never crosses the x-axis.
So there's no zero or there are.
Wait, how does that function never cross the x-axis? It's a happy parabola with a y-intercept of -2. You're telling me none of those 4 worked?
I didn't get any. Like I divided by all of them. The polynomial.
Oh, then it crosses at a decimal. That's fine. It crosses at an irrational spot. That's totally fine.
And then there's zero rational zeros.
Yeah, there's no. If none of those 4 work, then there's no rational zeros. That doesn't mean there's not a real zero. There's probably a real zero. Because if I were to graph that thing, not that this is part of this problem, but it's still kind of fun. If you were to graph that thing, we know it's got a y-intercept of -2. We don't know the x-intercept because you just told me it's way too hard to find. That's what you basically said when you said I can't find a zero. X-intercept is way too hard to find. I do know that it finishes happy, right? And that's why I was saying there's got to be an x-intercept. Otherwise, that doesn't make sense. It's okay for that x-intercept to be irrational or unfindable. So basically what this probably looks like is this. I could be wrong. Probably wrong. But none of these points are rational numbers. All of these points are irrational numbers. Perhaps it looks like this and it turns around too quickly. That's okay too. I don't know for sure. I haven't solved it all. But
Okay, so then for A, the answer would be there is none.
no, this is the answer. Possible. It didn't ask for zeros. It asked for possibles, right? That's really, really important that you see the word possible and know, oh, it didn't ask for what are all the actual zeros. It didn't say solve this thing. It said what are all the possible rational zeros. Your answer is that red box. I was just showing you what I didn't thought. I don't know. All right, what else? 9? Is that same one? Is that the one we were talking about earlier? Yeah. Okay, can I grab one of these? 3? Dope. Thank you. I can do the other one. It just will end up looking like this. We squared both sides. We did some FOIL. We got down to something. This wasn't the hard part yet. This is what it would end up looking normal style. Square both sides here. When we square that left side, we're like, oh, that's a fraction to be squared, not a normal thing. So we got that. Then we subtracted some fractions, did some common denominator stuff. ABC is fractions. Plug it into there. Get your. No. It will look like one of these 4, which we're about to do. The steps are the same. Square both sides, FOIL, then you're going to square both sides again. That's pretty much the steps. Let's watch that happen. Let me grab. I'll do the middle one. I haven't done any of these 3 yet because we were so tired after doing that long one that I went and looked up easy ones to solve. Said, go practice these. We'll solve them on Thursday. So let's. If you want to go do that, I recorded the video. You can go watch us struggle through it and learn about all these freaking fractions. All right, so here we go. Like I said, to get started, we're just going to square both sides. Get rid of those square roots. We don't like them. Square the left side. Square the right side. Left side leaves you with 2n plus 2. Right side leaves you with. This is where it's really not nice to just think you, like, what do you need to do on that right side? You got a FOIL, right? Or some people like to do it in the box. That's literally okay. The box is the exact same thing as FOIL. It just breaks it apart as a picture instead of with lines. So we got 1, root 2n minus 1. 1, root 2n minus 1. What's 1 times 1? 1. What's 1 times root 2n minus 1? Root 2n minus 1. Same thing. And then 2n minus 1 is if you square them together. All that is us multiplying the parts of the box. It's the same as FOIL. It's just a little bit prettier. Not much. So you're left with 1 plus 2 root 2n minus 1 plus parentheses 2n minus 1. I don't know why I had parentheses there. Did anything cancel? Holy smokes. So much is going to cancel. This is a great problem. This might be too easy. What cancels right there? Minus 1. Oh, no, it's not going to cancel. That's nice. That's nice, actually. Good. So 1 and negative 1 cancel with each other. If you subtract 2n over, cancels with that 2n. You're left with 2 equals 2 root 2n minus 1. Divide by 2, divide by 2. You're left with 1 equals root 2n minus 1. Square both sides. 1 equals 2n minus 1. 2 equals 2n. N equals 1. You know what I got to do? Check it because square root. Check, because there's a square root. Does 1 work? Left side, we get square root of 5. That's not true. Left side, we get square root of 4. Right side, we get 1 plus root 2 times 1 minus 1. 1 plus root 1. This is 2. This is 2. Check. And equaled 1 for that one. It's still long, but it's not as long as the first thing with the fractions. We don't have to do a whole bunch of fractions. Yeah. Just like zoom in. The top thing right there? Okay. Because the little one just means the first instance of it. Like, yeah. So because x1 equals 1, imagine this is just that red one from over there. And then we plugged it in to whatever the formula is for b. So plug in 1 right there. 4 times 1 is 4. Root 4 is 2. So this is just me plugging it into the equation. Whoa, chill. 4x. Where x is 1 in that case. Square root of 4 is 2. That's 4 times 1 not. Yep. Okay, yeah, just make sure. If you want to think of them as y's, you can. If you want to write y1, y2, just so you don't have to see f of x, and just know, oh, y is when I plug it in, you can do that too. Some people just write y1 there instead, and then never have to do any of that stuff. They just say, oh, what's y1? I don't know. It's when I plug my x1 in and get a number. That's fine. 15 minutes? We got enough time for 1 or 2 more? Maybe 3. Let's go see. Ooh, crap. That's good. Because this is so long ago. Okay, let's... I did a real long explanation of axis of symmetry last class. I don't think it was fruitful. So let's break it down into the simpler version. Here's the simplest version of axis of symmetry so you can remember it. Think about a parabola. Everybody knows what a parabola is, I hope. And if you don't, that's tough. Parabola looks like this, right? Where is its symmetry? Symmetry from like the 3rd grade, like mirroring. Where is it mirrored? Okay, right? Y-axis. Okay, now think about any 2 points on that thing. Think about any 2 points on that thing. 2, 4, right? What point is this point? What changed? X changed. What didn't change? More specifically, what happened to that X? Okay, so for y-axis, to think about this, for y-axis symmetry, I think this is the simplest way to think about it, is f of x is literally equal to, and remember we can think of f of x as the y value, right? What is the y value equal to? This is an important thing to notice. For it to be symmetric around the y, what was the same as f of x? Yeah. And that's it. That's the whole formula. That's y-axis. That's it. So all we do is go and plug that in. We go to our normal equation right there. And you know what we plug in? Negative x. And see what happens. So watch this. I'll do each of them just because it's fun. If f of x equals 2x minus 10, what does f of negative x equal? 2 times negative x minus 10, which is negative 2x minus 10. Are those the same? Are those the same thing? No, they're not. Look, freaking no. No. So, not y. Interesting. I'm going to skip to C because B doesn't again, and for the sake of time. So let's skip to C. F of x equals 3x squared plus 4. F of negative x equals 3 times negative x squared plus 4. What's negative x squared? This is cool. It's just x squared, right? They're the same thing every time. Are those the same? Oh, shoot. So guess what that is? That is y symmetry happening for that third one. Does that make sense that it's y symmetry? I don't know. Let's freaking think about the actual equation. That's a happy parabola that starts at 4, isn't it? Should that be symmetric around y? Yeah, because it's just a normal parabola starting at 4. That makes total sense that it should be. All right, but there was a different type of symmetry. There was one other type of symmetry, just one other one. There was y-axis symmetry. No, there's actually no x-axis. Why is there no x-axis symmetry, though? This is important. I'm going to say origin, but I'm going to say why is there no x-axis symmetry? What would that make it? The square root is an example of it.
Oh, that it would be from both sides.
And guess what that's not? Not a function. So it doesn't even make sense then. A function can't have x-axis symmetry because by definition, then it wouldn't even be a function. Now, you could say a relationship with two conditions could have x-axis symmetry, but not a function. Because if you take any function in the world and say, oh, look, if there's a point here, you can just flip it across x. Guess what? Immediately, you just did not pass the vertical line test. Like, immediately, even if the function's as simple as 1 point. So, no x-axis. But there is this thing called origin, which is a really similar formula. It just says that if f of negative x, it's not the exact same formula. You know what you do with that negative sign? You just throw it on the outside. And instead of doing those other ones, because I don't think any of those other ones were actually origin symmetry, the easiest thing to think of that has origin symmetry is a line. Like, think of the line f of x equals 4x. What is f of negative x? 4 times negative x. Is that the same thing as negative 4x? And 4x was f of x, right? Technically, isn't this f of x right up there? So it's negative f of x. Huh, look at that. Now here's the kicker. Does it make a sense that the line reflects across that dot right there? I don't know. Here's 1. Here's 4. If I go to that line and then I keep going, look at that. Ba-boom. Another symmetric across the origin thing would be the cubic function. Think about that normal cubic function. Pick any point, even if it's weird. Go all the way to the origin. And guess what happens if you go the same distance? You end up back on the line. Even if you go super close, it happens right there. Super far, it happens right there. Doesn't matter. That's origin of origin symmetry. None of those 3 examples had origin symmetry. That's why I had to make one up. Which means probably not on the final, if I had to guess. Probably a y-axis problem on the final. One more. We got time for one more. We're not leaving early. Yeah. 33A. Yeah, and then we can leave early. Find the inverse of a cubic root function or cube root function. Sure thing. Anybody remember those 4 steps for an inverse? Technically, there's only one step that's super duper important, but it is a 4-step process. Well, before that. There was one thing before that, technically. Because look at these equations. I don't even see a y. You just said change x and y? Step 1 was, oh, is that what you said? You said switch x and y. Yeah, that's the real step. That's the only one that matters. F of x turns into y. Step 2, x and y swap. Step 3, solve for y. Step 4, turn y into invert x, or inverse of x, or f to the little -1 sign. So, step 1 for part A would be y equals root 3x minus 3. Step 2 would be swap them straight up. X equals root 3 y minus 3. Step 3. Everybody got a hankering on which of those two things to move first? Plus 3, plus 3. X plus 3 equals cube root of y. Ooh, how do we get rid of cube root? Cube. Cube. Step 4. Well, hang on, let me finish this real quick. Y equals x plus 3 cubic. Step 4 is to do what? Just be able to recognize if it's multiple choice that those two things mean the same thing. Zoom out a second. It's pretty fun. That's a fun one. No, absolutely not. And on the test, I'm pretty sure the multiple choice doesn't have it factored out. Because that'd be a FOIL and then another 2x3 box. That's not pretty. So, no, it leaves it like that for this type of problem. And it looks pretty darn similar to A. I'm pretty sure this one looks like A. Could be wrong. I don't remember perfectly, but trying to remember. Kindred. Leslie. Carissa. Kylie. Alexis. Andrew. McKenna. Kelly. Carolina. Elijah. Jocelyn. Anna. Taylor. Amelia. Natalie. Marcus. Patrick. Raylan. Eric. Jessica. Destiny. Kenna. Sarah. Amelia. Maj. Jocelyn. Arian. Esperance. None. All right. Please, please, please go home.